Welcome back. Today we're diving into another explainer, and we are tackling a massive topic. We are going to teach you how to factorize in GCSE Maths, and we're going to do this by watching the equations get progressively harder. Think of today's journey kind of like a video game, right? We're systematically leveling up our algebra skills. We'll start from the absolute basics, the tutorial level, and work our way right up to the toughest, boss-level challenges the exam board can possibly throw at you. So grab your mental controllers and let's jump right in.
Here is our game plan for today. We kick off with the tutorial, Factorising Basics. Then, Level 1, Common Factors. Level 2, Difference of two squares. Level 3, Simple Quadratics. And then, the boss level, Harder Quadratics. Finally, we wrap it all up with the Ultimate Master Checklist.
All right, Section 1, the tutorial, Factorising Basics.
Now I want to promise you something right off the bat. Math is absolutely not about guessing. It's about having a reliable system in place. Once you know the system, the numbers literally just fall into place. So what do we actually mean by our main action verb today? Put simply, factorizing means rewriting an expression as the product, meaning the multiplication of two or more terms or brackets. Basically, you're taking a messy, sprawled-out sum and packing it neatly into boxes that multiply together. Each bracket becomes a factor of that original quadratic.
Let's look at this in action. An expanded expression, like 3x plus 6, is just something plus something. But the factorized version is 3, open bracket, x plus 2, close bracket. It's the exact opposite of expanding brackets. And you know what's really amazing about this? It gives us a built-in safety net. Because it's the exact opposite, you can always multiply out your final brackets just to check if you get back to the original equation. It's pretty foolproof.
Okay, moving to Section 2, Level 1, Common Factors.
Tutorial complete. You know the goal. Now, our main mechanic for Level 1 is super simple. We're hunting for the highest common factor shared by the terms. Here is our first enemy equation. 2x squared minus 8x equals 0. Lean in, take a really close look. What commonalities do you spot between that 2x squared and the 8x? Don't overthink it, just look for the biggest number and the highest power present in every single term.
Well, the solution is incredibly simple once you spot those elements. Both terms divide evenly by the number 2, right? And they both contain at least one x. So, our highest common factors are 2 and x. We write 2x right outside our bracket. Next, we divide our original terms by 2x. So, 2x squared divided by 2x just leaves us with x. And minus 8x divided by 2x, that leaves minus 4. Pop those inside the bracket and boom, our result is 2x times the bracket x minus 4 equals 0. Level 1 officially cleared.
Next up, Section 3, Level 2, Difference of two squares.
Excellent progress so far. Now, this next level doesn't actually need complex calculations. Instead, it introduces a highly specific visual pattern, and you want to train your eyes to recognize this instantly in the exam hall. Challenge yourself with this. Factorize x squared minus 9. Notice what's missing here. There are only two terms, and there's absolutely no obvious common x factor like we just saw in Level 1, because the 9 doesn't have an x attached to it. So how in the world do we tackle this?
The secret is right there in the name, the difference of two squares. First, run a quick check. Is it a subtraction? Yes, so that's the difference. Are both terms perfect squares? Well, x squared is x times x, and 9 is 3 times 3, so yes. The rule here is honestly just beautiful. You literally just take the square roots of both terms, which are x and 3, and you put them into two identical brackets. But here's the catch. You make one a plus and one a minus. Our result is simply x plus 3 multiplied by x minus 3. Once you know what to look for, it's lightning fast.
All right, Section 4, Level 3, Simple Quadratics.
We are leveling up so fast. Okay, now we're facing the standard three-term quadratics. These require a little bit of mathematical detective work. Check out this classic equation, x squared minus 5x plus 6. Notice how the number, the coefficient, in front of the x squared is simply an invisible 1? When it's just a 1, we call it a simple quadratic. But how exactly do we split this three-part puzzle into two neat little brackets?
We use what I like to call the number puzzle strategy. Here's the absolute crucial point. We have to systematically find two numbers that multiply together to give our end number c, which is positive 6, but those exact same two numbers must also add together to give our middle number b, which is minus 5. So let's test the factor pairs of positive 6. 1 and 6 add to 7. Nope. Minus 1 and minus 6 add to minus 7. Incorrect. 2 and 3 add to positive 5. Ooh, close, but no. Now look at -2 and -3. They multiply to make positive 6, and they add together to make -5. Bingo! We've got our match.
And once you've solved that number puzzle, you have essentially beaten the level. We just take our winning numbers, -2 and -3, and drop them directly into our two brackets right next to an x. So our final result is x minus 2 times x minus 3. Detective work totally complete.
Moving on to Section 5, Boss Level, Harder Quadratics.
Okay, take a deep breath. We have finally reached it, the boss level. These are the equations where the number in front of the x squared is greater than 1. This is usually where students start to panic, but you won't because we have a system. Look at this intimidating boss, 4x squared minus 25x minus 21. See that 4 at the front? That means our simple number puzzle from level 3 just isn't going to cut it on its own. It looks tough, sure, but we have the exact combo move needed to beat it. It's called factorizing by grouping. Let's break it down.
Here are the 4 logical, unintimidating steps. Step 1. Multiply your first number, a, by your last number, c. So 4 times -21 gives us -84. Step 2. Play the number puzzle with this new number. We need factors of -84 that add up to our middle term b, which is -25. After a little thinking, we find that -28 and +3 work perfectly. Step 3. Now don't jump straight to the brackets yet. We actually use these two numbers to rewrite our middle term. We split that -25x into -28x and +3x. And step 4. We split the whole equation right in half and factorize it by grouping.
Let's execute that combo move step by step. We've got our rewritten expression, 4x squared minus 28x plus 3x minus 21. We slice it right down the middle into two groups. Group 1 is the first two terms. What is the highest common factor of 4x squared and minus 28x? It's 4x. Pull that out, and we get 4x times the bracket x minus 7. Now group 2. What's the common factor for plus 3x and minus 21? It's a positive 3. Pull that out, and we get plus 3 times the bracket x minus 7. Look at the brackets. They're identical, x minus 7. That is the magic of this method. Because they're common to both parts, that becomes our first final bracket. Then, the leftover bits on the outside, the 4x and the plus 3, group together to form our second bracket. The final answer, x minus 7 times 4x plus 3. Boss defeated.
Section 6, the ultimate master checklist.
Honestly, amazing work. We have cleared all the levels, so now I want to give you a mental diagnostic tool. Take this directly into your GCSE exam. When you're staring down a question, use this rapid-fire decision tree to turn all those confusing choices into a really simple pattern recognition game. Does it have 2 terms only? Just take out the highest common factor. 2 terms, but they're perfect squares separated by a minus? Bam, difference of 2 squares. 3 terms starting with just an x squared. That's your simple quadratic. Find numbers that add to b and multiply to c. 3 terms starting with a number, like ax squared? Quick, check if that number is a common factor you can just divide out first. And if there's no common factor for that ax squared, roll up your sleeves, you're using the boss level grouping method.
And before we wrap this up, I literally have to emphasize this golden rule, straight from the revision notes. As a check, expand your answer and make sure you get the same expression as the one you were trying to factorize. Because factorization is perfectly reversible, you can always test it. Doing a quick mental expansion guarantees you have scored those points way before you ever hand in the paper. It's basically a cheat code.
And there we have it. You have totally leveled up your factorization skills today, going from simple common factors all the way up to grouping those really hard quadratics. You've got the system. You know the patterns. So, armed with this explainer's master checklist, I want you to ask yourself, what equation are you going to conquer next? Keep practicing, stay focused, and I will see you in the next one.